Now number 8, this one's a little trickier because neither of these are solved for x or y, and if I want to use substitution, one of them needs to be solved. In my mind, let's take this bottom one. It only has an x, so if I add 9, I can already get that x equals 8. I've got my first answer. So I'm looking for 8 something. Now if x is 8, let's throw it into the top. 2 times 8 minus y equals 23. So I have 16 minus y equals 23. Now if I subtract my 16 to get rid of it, then I'm left with a negative y equals positive 7. And then if I divide by negative 1 to get y by itself, I get y is negative 7. So I'm looking for the point 8, negative 7. That's my solutions, okay? If I were to graph those two, they would cross at 8, negative 7. That's what that means, okay? Number 9, solve the system by elimination. Elimination, remember, is where we want to add down, and we want to just combine our like terms here, and we want either the x or y to cancel. We need opposites. This one, there is opposites in the x's. If I do x plus a negative x, I get 0. 2 plus 1y is 3y, and 13 plus 5 is 18. I can solve for y because my x's disappeared, and y equals 6. I'm looking at my multiple choice. That's the only one with a y is 6, so I'm assuming x is going to be 1, but I can plug that in, right? So I can take the 6 and substitute it back for y right there. So that first equation reads x plus 2y equals 13, but y is 6. So that makes x plus 12 equals 13. So you can see if I subtract 12, I'm going to get that 1 that we talked about. Number 10, another solving systems equation. This time when I add down, I'm not going to get anything to cancel, so I'm going to have to manipulate a little. And my thinking is if I can make this x a negative 2x, then these will be opposites and they'll cancel when I add down. So I'm going to multiply everything in the top by negative 2. The new equation would then be this right here. I multiply every term by negative 2. The bottom equation, I'm going to leave it just like it is. We're manipulating so that we can get something to cancel. When I add down, I get 0x. Negative 2 plus 7 is 5y. Negative 4 plus 9 is 5. If I divide by 5, y is going to be 1. That leaves me right there right now. If y is 1, what plus 1 is 2? Or I can subtract 1 to find that out, and we find that x is 1 as well. And it's written as an ordered pair, 1, 1. Number 11 is the same idea. This time, this one's looking a little trickier. 2 times what is 13? I'm trying to create opposites. I can't really multiply 6 by anything to make 9. I can't multiply 2 by anything to get 13, so I'm going to have to manipulate both of these. And I'm thinking if I multiply the bottom by negative 2 and I multiply the top by 13, I'm going to get 26y and negative 26y. So when I multiply all three of those by 13, I get 117x, 26y, and 507. 13 times 39 is 507. On the bottom, I get negative 12, I get negative 26y, and I get positive 18. Now when I add down, the y's are going to cancel. This gets me to 105x. This gets me to 525. And then I divide by 105, and I get 5 for x. That's going to leave me right here. It's the only one that x is 5, but I can plug it back in. I can go back up to x right here. 9 times 5 is 45 plus 2y equals 39. I can subtract 45, and I get 2y equals negative 6. And if I divide by 2, I get negative 3. And that's where I'd get my other answer. Okay, there's number 11. 12. Determine the type of solution for the following system of equations. I'm noticing if I do elimination, the opposites are already in the x's. They're going to cancel. Oh, but so are the y's. If I add down right now, I'm going to get 0x and 0y, and then I'm going to get 2. 0 and 0. So I'm trying to solve for x and y, and they both disappeared. So it makes it impossible to solve. What I need to look at is what's left. If that's a true statement, then I have infinitely many solutions. If it's false, then I have no solution. This happens to be false, so it's no solution. Now, if I worked it out and got an answer, then I know I have one solution. Okay. 13. What will the solution look like for those two if I were to graph them? Well, in my mind, again, I'm thinking this going, well, if I multiply the top by -2. I'm actually going to approach this by elimination, right? And so the top is going to be -2x plus 2y equals 0. The bottom I'm going to leave it just like it is. And when I add down, I'm going to get 3x, I'm going to get nothing, and I'm going to get 6. So x equals 2. That tells me right now 2 minus what is 0. If I punch that back up here, that tells me y is going to be 2 as well. That tells me these two lines, if I graph them, are going to cross at 2, 2. The two lines will be parallel? No. If they're parallel, then I would have no solution. The two lines are actually the same line? No. If that were the case, the variables would disappear and what's left would be true. They will cross at one point. It's 2, 2, so I'm going to choose that one. Number 14, find the value of the two numbers. So I'm going to write the two systems here. Sum means add, so I have two random numbers. I don't know what they are. I'm going to call them x and y. If I add them together, I get 2. If I take the difference, meaning subtract them, I get 8. This is a great elimination problem. These are opposites already. They're going to cancel. X and x is 2x. Those are 1s. 8 and 2 is 10. Divide by 2, and x is 5. That's going to lead me right here. Now I can put x in right there. I can put the 5 in and finish solving that for y, do a substitution, and if I subtract 5 to get y by itself, I'll get -3. So 5, -3 is what we're after. 15, a business tells you all about vans. This is two different purchases. We've got large vans and small vans. We made one purchase of 5 large and 2 small, and it cost $235,000. We made another purchase, 2 large vans, 3 small, and it cost $160,000. So the two equations that I would set up right there is 5 large, 2 small, and the total was $235,000. My second scenario was 2 large and 3 small for $160,000. Now again, I'm going to choose elimination here. You could do substitution. It'd take a little bit, but it will for elimination as well. But in my mind, if I multiply the top by -3 and the bottom by 2, what that's going to do is give me -6y, and it's going to give me +6y, and those are going to cancel, and I'll be able to solve. I'm going to rewrite those equations like this. 3 times all of that makes -15. It makes -6y, and it makes -705,000. And if I multiply all the bottom by 2, I'm going to get 4x, I'm going to get 6y, and I'm going to get 320,000. The nice part is we now have opposites. Those are going to go to 0. -15 plus 4 is -11. When I do -705,000. So if I did my multiplications correctly, this is where I'm at. My 6's cancel. I get -11. I get -385,000. If I divide by -11, I get 35,000. Once I get that 35,000, I can actually plug that back in. I could go right back to one of these originals up here, and I could say, well, it's 2 times 35,000. Let's see. Plus 3y equals 160,000. And then 2 times 35,000 is 70,000. Okay, and then to finish solving here, I can subtract 70,000. And when I subtract 70,000 from 160, I get 90,000. And then I divide by 3, and I get 30,000. So the large vans are 35,000, the small vans are 30,000. And there's the answers I'm looking for. That concludes our 15 problems. Thanks for watching. Good luck on the test. See ya.